So today we are specifically talking about rectangles and squares. So we already know that in our sort of hierarchy of shapes here, we had the quadrilaterals, and then an offshoot of the quadrilaterals were parallelograms. When I say offshoot like this, that means that because a parallelogram is a type of quadrilateral, everything that was true about a quadrilateral is automatically true about a parallelogram. Okay, so all the things that we said about quadrilaterals, that they have 4 sides and all of their angles add up to be 360. That's still true for a parallelogram because it's like a descendant of the quadrilateral. So everything that was true up here is now true for the parallelogram. And so now as we shoot off of parallelogram and we go to rectangle, that means rectangles also inherit everything that was true for not only the quadrilaterals, but also everything that we learned about parallelograms. So all the stuff that we learned, like their opposite sides are always going to be equal for a parallelogram. Their opposite sides are going to be parallel, obviously. The opposite angles are equal. The consecutive angles are supplementary. The diagonals bisect each other. All of those things that were true for parallelograms are now also true for rectangles, because they came from it, right? It's just a smaller section of it. So rectangles inherit everything that parallelograms have. So let's even write that down. I'll put it over here. Rectangles have all of the properties that quadrilaterals and parallelograms have. Remember our symbol for parallelograms if you don't want to write the word out. Rectangles have all of the properties that quadrilaterals and parallelograms have, plus they do have their own. So there's a couple things that are unique to rectangles that are not true of every other parallelogram. Okay, and I'm going to use my my bendy shapes to show you. Okay, so let me zoom out a little bit. Here is my parallelogram, right? So we've been using this same shape over the last couple days. We talked about if I draw in the 2 diagonals, right? They do bisect each other in every parallelogram. That will always be true if you have a parallelogram. What's not true in every single parallelogram is the length of those diagonals. See here, I have one super long diagonal, and then I have one little short diagonal, right? So the lengths of the diagonals in a parallelogram are not always going to be the same as each other, as seen here. We've got a really long one and then a pretty short one. Okay, so diagonals are not always equal unless you just so happen to have, check this out, look at what happens when this thing turns into a rectangle. Now, if you look at the length of these 2 diagonals, it really does look like it's equal. And I don't know if I have a piece that's going to be perfect, but is this one perfect? Oh, no way. So hold on, there's a purple. And now when I take another purple, you'll see that it matches perfectly on the other side. I didn't know that the purples were going to work out so well. Look at that. So you can see that the diagonals in a rectangle actually really are equal to each other. The entire length is going to equal the other entire length. So what that also means is that, now remember, the rectangle gets all the properties that the parallelogram have. So not only is the entire purple equal to the entire purple, but since it's still a parallelogram, these 2 purples are still bisecting each other. So now you have these 4 little pieces, and they're all going to be equal in a rectangle. Oh my gosh. So let's add this to our big list because this is super important. So rectangles have all of the properties that quadrilaterals and parallelograms have, plus they have congruent diagonals. So we're going to add I don't know, I'll put a star. I gotta change colors. This marker is not, it's really not even that old of a marker, and it's already just crapping out on me. Plus, rectangles have congruent diagonals. They are the only parallelograms that have congruent diagonals. Nobody else does, only rectangles. Only rectangles. A rhombus doesn't have it. Regular old parallelograms don't have it. Only rectangles. So this is something very special to just the rectangle. So let's draw a picture of it. So we have it here in our notes too. All right, so that's the big deal with rectangles. Obviously, they have to have 4 right angles, otherwise it's not a rectangle. All right, so there we go. We have our rectangle. And then if I draw in those 2 diagonals, okay, so the fun facts today is that they're all going to be the same. So AC, the entire length of that diagonal, will be equal to the entire length of BD. Oh, that's not a D at all. There we go. All of these small pieces are going to end up being the same. So yesterday when we had parallelograms, we just had like these 2 were the same as each other, and then these 2 were the same as each other. But now we get all 4 pieces the same as each other. So if I just tell you the length of AE is, I don't know, 6, now you know that that's 6, and that's 6. Everybody's going to be 6. And then you could tell me the length of the whole diagonal is 12, which means you could also tell me the length of this diagonal, BD, because they're the same. Wow. So that's kind of the big deal about rectangles. They have congruent diagonals. And then the only other thing that we have to talk about is squares. And really, there's not much to say other than where do squares fit in over here? Well, parallelograms come from quadrilaterals. So parallelograms get all of the properties that quadrilaterals have. Rectangles come from parallelograms, so they get all of their properties. Well, guess what? Squares come off of rectangles. So squares get all the properties that rectangles have. So what does this mean? This means that squares also get congruent diagonals. No way. Yes, way. So let's add a big star. I don't know. I'll put it right here, and we'll just say, since squares are rectangles, they too have congruent diagonals. Oh, sorry, you can't even see it. Since squares are rectangles, they too have congruent diagonals, and I'll even add as well as all properties of quadrilaterals and parallelograms, because they are them too. So a square is a rectangle, and a square is a parallelogram, and it is a quadrilateral. So it inherits all of those properties as well. Let me give you a minute. Let's just get that down if you haven't already. I'll do a couple problems with you guys, and then you will be on your own to do the assignment. Anybody have any questions so far? Okay. So, assuming everybody is done jotting that down, let's go ahead. I am out of pages in my notebook. So as soon as we end, I'm gonna find more pages. All right, but that's okay. I have some space on this one. So let's try this. Let's do a rectangle problem and then we'll do a square. So here is a rectangle. And let me give you some questions about this rectangle. Okay, everybody ready? So I just want you to unmute yourself and just call out. If you want to send in the chat, that's fine, but be ready to answer. You ready? All right, pay attention. Listen, if AE is 7, what's EC? Fast, lightning fast.
7.
7. What if AE is 7? What's ED?
7.
7. Yes, you couldn't do this yesterday in a parallelogram, but if it's a rectangle, they're all going to be the same. All the pieces. All right, what would the length be of BD?
14.
14. See how easy this is? Okay, let's step it up a notch then. Let's say that instead, let's say this was 2x plus 3, and let's say this was 3x minus 1. Solve for x, please.
X equals 4.
Ooh! I'm not saying if it's right or not, so everybody give it a shot. Oh!
4.
I got another answer of 4. Okay, hang on while I update attendance here. Oh, shoot, it's going to freeze my camera. Oh, no, it's still on. Oh, well, okay. Oh, is it? Wait. Dang it. I forgot that I can't change the screen without it freaking out. Sorry. But those of you that said 4, you're correct. It is 4. I do have to restart my camera. Ugh. James, FYI, class started, oh, I don't know, 40 minutes ago? Wow, we're 40 minutes through already? See how time flies when you're having so much fun? All right, well, we are almost done. Hang on. Ay, ay, ay. All right, so yes, you should have gotten 4 for this because you should have just set these two equal to each other. Now, would anything have changed if instead of that piece being 3x minus 1, if I had made this piece over here 3x minus 1? Is there anything different? No, they're still equal to each other. This is different from yesterday. Yesterday, you couldn't have done this because all 4 little pieces weren't the same yesterday. I would have had to give you stuff on the same diagonal, but now I don't have to. It's so cool. All right, let's do one more. Well, let's do a square, and then I'll let you guys go. All right, so this thing is a square, and let's try this. So all the same things hold, but let's try, if I gave you this, see if you can answer me this. Say I told you that all of AC was, I don't know, 10x plus 4. So let's make this 6x plus 1, I guess. If that's your scenario, can you please solve for x, given that this thing is a square?
X equals 1.
Ooh. I make this 10 a little bit darker. I'm not saying if it's right or not just yet. I'm going to give everybody one more minute. You can send it to me in the chat. You can give me your answer when you got it.
1.
Okay, looks like we are agreeing on 1, and I agree as well. Would it have been any different if I had told you that this was 6x plus 1 instead of this? No, it doesn't matter, because in a square also, all 4 of these little pieces are going to be the same. And that's it. So that's all that I had to tell you about rectangles and squares. Does anybody have any questions right now?
No. No.
All right. So